Hey everybody, how's it going? Um, so I just had a geometry live stream, so I just finished with that. That was great. I made them an inspiration, or I made them a video. So I got an inspirational video that I whipped up in the last 10 minutes. I used a template, and I edited some stuff. So I'm gonna begin with this video. So pay close attention, and I think we'll be good. All right, here we go. All right. So that concludes our Q&A. I think that pretty much covered everything. Um, so if there's nothing else, I think we're done. Um, nope, I made that for you guys. So pretty good, right? Uh, there's a slide that had a paper airplane on it, so yeah, I had to use it. Anyway, I'm here. How's it going? How's everyone doing? Um, I feel like I've lost a lot of people already after just simply 2 minutes. Um, we're 5 minutes in, but anyway, we're doing fine. Yes, look, I got my comp sci shirt on. Okay, so basically, I mean, I don't know how long this is going to be. The idea is that I've told you it a bunch of times. The test itself is sort of a mock AP test. There's not, yeah, knowing the information is important, obviously, but sort of applying that information to different situations. Um, so there isn't anything that I didn't already cover on a live stream, pretty much, right? The sort of hexadecimal conversions, of course, part of it. Just dealing with, binary in general, what it means. That ASCII table, and most of us, I mean, had access to our tests. I mean, if you weren't there, you happen to not. But if you were there those days, the last review days, we had access to our previous tests to go over them, so to get us an idea, right? There, the review AP test. I mean, or it's a sort of a mock AP style test. So it's sort of more application than anything else, but it is. Again, the tips weren't fake in the video. It really is like if you have a pretty good grasp of the information and then are able to apply that information in certain in context of different questions, we should be good. Um, of course, knowing that information is important or being able to piece together stuff um, with different vocabulary. Again, they love algorithms, they love abstraction, they love the programming snippets where you're following through with the code, the selection and iteration. So all those, I mean, I gave you those review problems online to do. So if there's any of those you wanna look through, I know I probably over-assigned a bunch of them. Like I said, I assigned them multiple times probably. But the like from the last review and then this one as well. But still, I think we're. Um, oh, you guys might have been asking questions. I literally had the chat covered up. So let's see. Nope, no one said anything. Cool. I hope my mic's working and people can actually hear me. Otherwise, it would just be kind of embarrassing. Um, maybe you're just so entertained that you didn't want to type anything. But just say something there. Or where my chat is over there. But okay, but the idea is say something so you can, I know that you're hearing what I'm saying, right? Cool. Also, there was some sick music for the video, so I'm cool. Piper, thank you. So again, I don't like have a particular curriculum that I'm gonna like follow through. Like geometry, it was a little bit more thorough, a little more easier because we had um uh I mean, there's sections 6.1, 6.2. I mean, we started with 1.1, blah 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 blah. There's a curve. I'm not. I mean, maybe, but probably not. I mean, the idea is if we need it, who knows? There's no set one, certainly. Again, uh, if there was a curve, all you have to do is do better than everyone else, and then boom, you're the highest. But again, it's not really anything set. So you go in with the mindset of you can get all these right. There's not one that is going to be like, oh, they're not going to get 10 of these questions right, so we're definitely going to. No, it's very doable. Like you guys can do it. I will say that when previous tests have had specific questions to App Inventor. And again, we talked about this in class where, because the AP test doesn't use App Inventor specifically, they use just they don't even use this particular language. They use a broad language that sort of applies. We have to make sure we can move over our concepts that we've learned in loops and selection and if statements and things like that, move those concepts over to just sort of a generic one, block statements and stuff. So, sheep and goats. Okay, wait, sorry. There's a few. Okay. Questions I didn't understand in the AP Classroom. Uh, Hold on. There's a lot of questions now. Whoa. Okay, so sheep and goats. Do you know what question number that was? If you just want to give me the number so I can find. I'm gonna have to find it real quick, and then we can go over it. Lossy, lossless, sure. So I'm just gonna get to these when we get them. Where's my pen? Oh, there it is. Sheep. Again, I don't remember which one that is. Goats. Lossy versus lossless, and that's compression, right? So that's just compression in general. I'll have to touch on. That's supposed to be a C. Compression. There may be more. Misunderstood topics. I don't know. Well, maybe I'll think of some. Okay. Okay. The World Wide Web. That's a. What? I was just gonna make all the W's at once, but instead I made two weird W's. W. That's it. Nailed it. Okay. I mean, the vocab is all the stuff we've talked about, right? There's no like vocabulary list. I mean, it's everything. What is compression? We had talked about what encoding. We talked about um, sort of your privacy stuff, right? That was all blown to bits stuff that we talked about. We talked about the programming concepts of selection and repetition and sequence, right? We talked about iteration, the iterative development process, right? We've talked about we have talked about World Wide Web and the internet or versus the internet. We talked about persistent data. Like there's the words that I said repeatedly and over throughout the class that we have, but there's no like particular list. Like I mean, I don't. We'll see them in the questions that we happen to do. Again, I gotta actually log on to that site and do that. So I'll do that now. So if you have any other things, just give me a second to try to log on and get to that question. Someone actually want to find it. Someone thinks it was 8. Cool. So Tyler did. So let me see if I can find that. Just give me 1 sec, and I will be right back. Just so you're not bored, I'll play that video again while I'm looking. I'm logging in now, but I'm looking through them. So all right, just so you're not bored.
Mic off.
All right. Sick. I got it. All right. So I don't have them up. I will pull them up. Um, Oop, that's the wrong one. There you go. That's the right one. Oop, nope, stop. Okay. So, all right, as far as this goes, okay, so the number 8 isn't the sheep and goats one. Let me just flip through them to see if I can find them. Was it 7? Yeah, cool. Okay. I'll see if I can pull this up here and maybe get that there. Look, there I am. Haha, there's my stuff. All right. So I'm going to see if I can maybe work it out on this page, and we can read it on this page. And maybe we can read that better there, and I can go right here. Where's my pen? Got it. We got it all situated. Cool. Okay, I'll come back. But anyway, so this is number 7. So it's the sheep and goats. So I'll just read it real quick. Again, I'm doing this sort of cold here, but I've seen it before. A programmer completes the user manual for a video game she has developed and realizes she has reversed the roles of goats and sheep throughout the text. Consider the programmer's goal for exchanging all occurrences of goats to sheep and occurrences of sheep to goats. Okay, so the programmer will use the fact that the word foxes does not appear anywhere in the original text. Okay, so this is sort of a concept that happens a few times, and again, just it's a general thing is that okay, let's just think of these as variables, right? I mean, I don't really care what they are, but I mean, I have 3 variables, right? I have G, right? I've got S, and I've got um, F, right? So goat, sheep, foxes. But the main thing here, and just to think about it, is that if I replaced in my text, right? If I had a word and I replaced all goats to sheep first, right? Well, that means sheep are still sheep. Goats are still goats, right? So, or sorry, goats are sheep and sheep are still sheep. So there's a ton of sheep in there. So how am I going to differentiate between them? So the idea is I can't just do what I would think. Oh, hey, I can't just say it like verbally. I can't just, or like how I would think about it. Okay, just change goats to sheep and change sheep to goat. I can't do that because once I do the first one, then it loses. Then I lose which one I'm looking at. So if we think about it when we're dealing with variables, right, is that um, we have, and this is sort of this could be this principle is sort of covered in this question, but I'm going to just do it using variables because let's just say the value of G is 10, the value of S is 6, right? And I want to swap them. Well, if I said, all right, you know what? If I want to swap what G and S is, if I said, okay, we'll just set G to what, set G to what, stop that. Why would that be a thing? Okay, I'm furious. Anyway, set G to what S is and set S to what G is, right? If I did this, right, the first thing that would happen is like the value of G like would change to 6. Okay? But then when I try to change S to what G is, well G is now 6. So now it's going to change, so everything's going to be 6, right? So the whole idea is that it doesn't actually swap them. So I need a you can do it, Natalia. I believe in you. Congratulations and all, but what would Duke want you to do? Think about that. Okay? Think about that. Um, all of they are the Blue Devils. So it's like Blue Devil, Angel. I don't know. Anyway, honestly, I think I included some of you had Molly just as a quick aside here. I put all of them, like I repeated them. You guys had bell ringers a lot of times, so like you did them all just incrementally. I think I added a few ones that aren't relevant. Like I was just flipping through them quickly. So yes, you had more, but we had essentially the same questions. Just mine was in one big chunk. Yours were sort of spread out. So that's fine. RG, Blue Devil, love it. All right. Love everything about that. Okay, anyway, so I can't just do this. So what I need to do is I need to find a spot to temporarily put this value in G, right? Sort of a temporary spot. So I can say, all right, you know what we can do? Let's get this temporary variable involved. And so let's say, all right, let's take the value that's in G and put it in a temporary value. So I'm not going to do that. I'm going to say, right, we have F. So I'm going to set F to the value that G was, right? So now F becomes 10, right? Then I can set G to what S was, right? Because that would change G, why I did that, that would change G to 6. But then the good news is I can actually then, right, I have a place where I stored that 10 already, where I stored the value. So I can then change S to that value that F was. So it's sort of a cycle here. It's like I'm sort of saying, all right, you know what? We want G to put its value in F, and we want S to put it G, and we want F to S. So it's sort of like we have this temporary value that's sort of storing it, and that's the idea, is that you can't just swap two variables very easily. You have to have like a temporary third thing, and that's where the foxes come in, right? That's what in this particular example, it's saying, hey, foxes doesn't appear anywhere in there, so we know that if I change something to foxes, there were no like fox mix-ups, right? So the idea is just if we look at it in this context, um, we can just say, all right, if we change goats to sheep, then sheep to goats, and we need to do something to foxes. So we can change goats to foxes, right? Then sheep to goats, then foxes to sheep, right? So we're basically, so I think it's C. Um, so in other words, we're basically saying, okay, if we change all the goats to foxes, like the word goats to foxes, then we have a bunch of foxes in there where the goats were. Then we can change sheep to where goats were. So then wherever we had sheep, goats is there, which is what we want. Then because we didn't have any original foxes, we can change those foxes, which is like it's just like a placeholder. It's like a temporary placeholder of the word foxes for sheep. So it is C in that case. I know I did a roundabout way, but that concept I've seen on every AP test like over and over again, where you cannot swap variables. You need a temporary value in there, right? And again, sometimes it just is as simple as like if I just wanted to swap variables, you would say like X goes in, you put the value. Actually, it's the way around. Where is this stupid whatever? In other words, we would put in the value X into temporary. We would replace X with Y, and then we would replace that the Y value with what was in temporary, which is what we originally put X in. So it's like it needs 3 steps. Okay. All right. So that was again, that was a bit of uh, full explanation, but hopefully it involved the arrows and the variables, and I mean I included that stuff as well. So hopefully that helps with other questions as well, and not just the goats sheep situation. That's the idea, is that hey, once you replace goats with sheep, then they're all goats. I mean, you guys are all the goats, but like, if you know what I'm saying. Got it. If you did that, that would have been cool. Okay. I'm gonna go back up. I'm scrolling. I'm scrolling upward. All right. Okay. So 9, 10, and 13. Someone asked again. Allison Key. Our numbers aren't the same. So that's why you're gonna have to probably describe what they are a little bit, and then I can touch on them. So again, because yours aren't the same, because you're not in my class, you just have to be more descriptive. Then I can find them. So it's the only type of selection statement an if statement. There are other types of selection statements. We really haven't covered a ton of them. There are switch cases. The idea is that a selection is just a place where you have a choice, right? Where you have two paths to go down. If something is true, go down one path. Otherwise, keep on going or go down a different path, right? So that would be your if or your if else, right? So that's the only idea, is you're selecting a path, right? Um, that's why it's called selection. For our case, if statements are really what you're going to look for selection statements. But if at any point but if it asks you sort of verbally, it's just a point where you're deciding. So if I wanted to decide whether or not something is an even number, I know I'm going to need an if statement, right? Because I'd have to say, well, if it's even, well, actually, I'd probably say like if num mod 2 equals 0 or whatever, right? But the point is that, hey, if it's even, do something, otherwise do something else. So whenever you're asking yourself a question, if something's the case, if it's bigger than 5, if it's even, if this number, if the text equals your name, whatever it is, like you're just literally saying the word if. You're deciding if something is true, do something. Right? So those are our selection statements. And again, in words, but also in concept, and also in block form, it's probably going to be an if statement. I think that's the only one that's on this particular test. But there are other ones, but don't worry about those. Where am I looking? I already answered Molly's question, I believe, about that. list questions. Again, if you could be, Isaac, if you can be more specific about which questions those are, I'll be happy to walk through the list ones, right? So the ones involving lists, I'll be more than happy to do that. You have the algorithms like the block things with the eyes. Okay, again, if you're in my class, be more specific with the problems, numbers. I mean, I could flip through them, but okay, please find them. All right. I mean, there are some free responses. Basically, yeah, there are free response. It's like a free response section. Most is multiple choice. And just like our previous ones, we have, select two right answers, just like we've had in our tests before. But there's also a couple, or there's some free response. Okay. Yeah, they are really short. Yes, the free responses are very short. It's, again, I would almost consider it mostly a majority, big time, of multiple choice. Molly, misunderstanding is most okay. Good. People are describing helping each other. Good, good, good. When it says 1 comma 3, does it mean 1 and 3? Okay. Are you talking about random? Random 1 comma 3? Is that what we mean? Again, Molly said. And this is what I'm guessing. So correct me if I'm wrong. Malls. People call you that. I don't know. It doesn't really matter. Okay. In other words, if it said like random and then 1 comma 3, that if you look at the reference sheet, it actually does mean it picks a random number from 1 to 3, including 1 and 3. So that would be a random number, either 1, 2, or 3. That's what that would be. A random number of that choice. So 1 comma 10 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be your possibilities. Okay. Um, so I mean, you can have parameters like here that do other things, but if it's talking random specifically, then that is what it does. Okay. Okay. So Cameron, heuristic we didn't talk about yet. So if there's a question about heuristic that I included, that was an accident. So you can anything that involves heuristic, we're good. I will 100%. You definitely have to know what it is. There's definitely going to be one in the actual AP test, a question about those, but that's a second semester thing. We didn't talk about them yet. So. Yeah. And let's see. Heuristic 4, 10. Okay. One more time. I'll be happy to do 4 because Jet, you're totally in my class. Appreciate you giving me a number. I'll look at 4 right here. Hopefully that is this one right here. As for the rest of you, right, who aren't in my class, you got to describe the question a little bit, right? Because I don't have the same numbers as your class. There's no way to assign them to every class, so we have different ones. So whatever number you said, can you do number 10? I can look at my number 10, but I don't think it's going to be the same. So you just got to ask, okay? Ben and Diane. Oh, there's a Ben and Diane question. Okay. If someone in my class wants to find that number, I'm going to do 4 for Jet, and then we'll do Ben and whatever. Ben and Diane is 23. Thank you. All right, so I'll do 23 in a second, but let's do this one that's up here. I'm going to actually do a little snip situation, and I'm going to, wait, come on, just so I can write it on here and use the whole thing. Okay. Okay, so we're looking at this question. So first of all, we're saying there's a variable called count. It actually says that. Uh, well, again, read what it's supposed to do. It's supposed to display the average of all the elements in the list. All right. So if I had the list of 1, 2, and 3, it would display the average, which in this case would 2. So it would display 2. That's the point. Okay. So typically it's good to have a uh, a test list that you're using. It should be probably pretty simple, one that you already know the average to. All right, but so I'm going to use that list just as I go through it, but we can go through there. We can walk through it, I should say. So it says we have a variable called count, and we're setting it equal to 0. So I have the variable called count. It is now 0. I have the variable sum, and I'm setting it to 0. And it says for each value in the number. So in other words, there's 3 values in my numbers list. So I am going through each value, right? And so the value is going to be 1, then it's going to be 2, then it's going to be 3 in my list of numbers. Again, that's just sort of iterating through a list here. So hopefully this answers some list question as well, maybe. And what are we doing? Well, we're setting the count to the count plus one, so we're increasing it. We're incrementing the count by one every time, so that's average. So we're setting the count was 0, but we're setting it now to the 0 plus 1, so that's just 1. So we're just going up by 1. The sum is increasing by the value, so the sum is 0, so it's going to be 0 plus the current value, which is the first value here, right? So we add 1 to it. Okay, and then we take our average. So we have a new variable called average. I'm just going to abbreviate it, and it's going to be sum divided by count. So 1 divided by 1 is 1, which makes sense. Okay, so it's calculating the average, so the sum divided by count. So it looks like it's actually working. And if I keep on doing this, the count is then 2, the sum becomes 3, right? And the average becomes 3 divided by 2, which is 1.5, which is the average of 1 and 2, right? Then the count becomes 3, and the sum, right, becomes 6, and then 6 divided by 3 is 2. So the average is changing every time, and that's fine. It's sort of, and the sum is changing. It's every time we're adding up the numbers. Fine. So it looks like it's working fine. So let's look what the question is actually asking. The programmer wants to reduce the number of operations. Okay. So again, we have a loop. This is our loop. So if you want to reduce the number of operations, you got to figure out what's going on in this loop. So this is our loop. This is the thing that's repeating however many times the list, how many numbers are in the list. If there's a list of 1,000,000 numbers, it'll go 1,000,000 times. So if I can reduce the amount of things that are happening, that's a good to reduce how many times it's running is faster and things like that. So it says what will still be a correct program, but will reduce the number of operations. And then it gives you some options, right? But the idea is there anything is there any one of these things, either this, or this, because these are the things that are repeating, any of those things that I could do not in this loop, right? That I don't need to repeat. Well, I need to keep track of the count, right? That has to happen, right? Every loop. I have to add the number to the sum, right? But this last one, I actually don't need to do this until the end, right? Couldn't I just keep track of the count, keep track of the sum, and then instead of calculating it every time, just calculate it once at the end, right? So the idea is if we swap lines 7 and 8, then we end up closing this brace here early, and so we keep track of the count and keep track of the sum forever, keep going through it. But then we just calculate the average one time at the end. It's still going to calculate it correctly. It's still going to find the average, but it's not doing this. Again, if this list was 1,000,000 numbers long, well, it would be doing this 1,000,000 times when it just needs to do it once at the end. Okay, so that is so the answer was swapping 7 and 8 because that's just basically making that one unnecessary. That the statement is necessary, but it's only necessary to do it once, and so we can leave it out of the loop. So we're out of the loop here. All right. Wow, great job, me. Okay. So a little ditty about Jack and Diane is number 23. Actually, it's Ben and Diane, but Jack and Diane is that song. So I don't know if there's an easier way, but I don't think it is. Okay, 19:2. Got it. Yes, totally can. But this one is supposed to. Oh, 23. No, I am on 23. Oh, yeah. Oh, I guess you're talking about this. Yeah. Sorry, I didn't. It is the right question. The correct question. All right. Sorry, guys. I didn't read the answers. Okay. So it's basically saying we're making a procedure. And it's basically the procedure is finding a name in a list. So here's the name that I can't write on it, but here's the name we're looking. Can you see the cursor? I don't even know. Here's the list of the names, and here is the actual name we're looking for. The index starts at 0, and we're going through every name in the list. We're adding 1 to the index every time, so we're incrementing the index to move on to the next one. And remember, the index is not what's in the list; it's the number of the value of the thing that's in the list. Okay. And so it says what's not going to work as intended. Well, let's just go through this. Let me just look at what the problem is. Okay, so it looks like we are. So we're going through every name in the list. So again, we could have one of these lists down here. And we're saying, okay, so here's our list, right? Andrea, and Ben. So if the name is Ben, we're going to set that found index to the, we're going to set the value to the index, right? Um, and then we're going to display the index, right? Hmm. Right? So we're actually giving the index of it. Okay, so in this case, right, the first one, it's Andrew is not found, right? It's not the target name. So else we set the index to the found index is 0, right? So the index is not in the list, so it's 0, right? Then we find the index at 1. So now the index is here, right? So it's gonna add 1 to it. And remember our indexes are 0 and 1. So we have 1 here, so that looks like it's gonna be fine. I think here's the problem. Okay, and I think I see it just from looking at it, but uh, if we have this is going to run every time, right? So it's saying, hey, if the name's in the list, set the index to the value that we want. Otherwise, set it to 0. Okay, so the thing is that if we have this list down here, right? If we're looking down here at this one, well, it doesn't find it, finds it here, so it sets the, so again, we're trying to find Ben, so it sets the index to the right index. Okay, awesome. Here, well, this one clearly, I mean, like we're trying to find Diane in here. That would actually be fine because the found index is 0. That means if it's not found, it should display 0. It says that up here in the problem. So awesome. It doesn't, we're trying to find Diane in this list. It's not there, so it's 0. We're trying to find Ben in this list. Okay, well, Andrea is not found, so the index is 0. Ben is found, so we set the index to 2 or whatever it happens to be, right? And then Chris comes along and it's like, well, Chris is not found, so we set the index back to 0. But that's not true, right? So it's going to give us a found index of 0, even though we want it to be, or we want it to, because it's saying, hey, Chris isn't found, so we set the index to 0, but Ben was found. So like this isn't going to work as intended. So the answer is C, um, because again, it's sort of like it works when Ben's at the end of the list, and it works when it's not in the list at all. But if this value happens sort of in the middle, well, it's going to keep on running after that. Like it's going to keep on going and end up setting the index to 0 afterward. So the answer is C. I mean, obviously you can check the answer, but that is why it is because it ends up setting it after the fact. Um, I don't even know what question you want. Is past your bedtime? What question are you talking about? Oh, we did that one. Okay, cool. 4 Diane 20 23 is the name one. That's this one. Got it. Um wait, 19 and 2. All right, so we'll do 19 and then we'll do 2. Okay. And then 8 then it looks wait, didn't we do question 8 already? Yeah, I'm pretty sure I did, Katie. So if you can always look back at that one, I think. Also, there's 32 viewers and 13 likes. There's something wrong there. I don't know what it is. Anyway, okay, so let's take a look. So programs 1 and 2 are intended to calculate the sum of the integers from 1 to n. So if we have 5, it's going to calculate 1 plus 2 plus 3 plus 4 plus 5. Okay. And we're assuming that it's a positive integer, so no negatives, all that good stuff. Okay. So if we walk through these things here, let's see if they're both right or which one's wrong. So if we the idea is to try to find like sort of an outlier, when it would not work. But okay, so we have we set I to 1. We set our result to 0, and then we're going to repeat it however many times we're in the list. That makes sense. That's the same of both. And so what we're doing is we're result equals result plus I. So again, if our list was 1, 2, or sorry, if our number was like 3, then we want to calculate 1 plus 2 plus 3. Okay, so we start with 1. And so we're gonna then we add 1 to I to make it so our result becomes 1. Sorry, because we add 1 to it, and then it becomes 2. So we add 2 to it, then it becomes 3, and we add 3 to it, and now we have 6 as our result, and then we display the result. So it seems as if this program 1 seems to be working fine. And then let's do the next one. The next one is we're going to set I to the value that we're looking at to 3, right? Again, if you notice that I'm not just saying, oh, look at them and figure and do this in your brain. That shouldn't be really a process. The process is, I mean, what I'm doing. It's this should be written on your paper. It's write down the variables, keep track of them as they go, and then and see if it's working as it should be or if it's something's not working. Um, comp sci, right, Talia? There we go. Wait, it's on my. It doesn't really work. Okay. Cool. We'll high five later. Anyway, so we have the same. We still have results. We're still repeating it n times. All good. We set result to 0, just like we did before. In this case, our I starts at the top value though. Um, and so okay. So our result, we add 3 to our result. Or in other words, we add I to it, and then it says I becomes I minus 1. So we set I, and in other words, we take our value I3, we subtract 1 to get 2, and we reset it as I. So now it's 2. Okay, so then I is, so that was 1 time. So then we add that 2 to our result to get 5. And then we do it one more time to make it 1. We add it to 6, right? So one list starts at I and goes up. So it starts at 1, which is the value, and goes up to our number that we're looking for. The other one starts at n and goes down. But we're still hitting all the numbers. So both of them work as intended, right? Both program 1 and 2 display the correct sum, right? So they both appear to be working. I'll be very mad. Furious. So you can write all over the test. The test is yours to write on. There should be, I mean, there should be plenty of room on the actual test. You also have the reference sheet to write on. If you really needed extra paper, extra room, you'll definitely have plenty of time. Okay, is that the one that I just did? Yeah, I think it was. Mystery procedure? No, totally not it. Sorry. Okay, so I'll see if I can find that one. And then someone asked about question 2. Oops, stop. So I'll do 2. Okay. So again, if you notice, I'm not like we're reading the question. We're not expected to read it and no, just okay. All I'm saying is I think this is one of those tests that like if you've studied for the previous ones and understood them, yes, studying is going to be helpful. Doing more problems and practice problems is going to be helpful to do because you'll see how things are worded and all that good stuff. But it's kind of one that it's hard to study for completely because it's using the concepts more. So I'm going to say you would if you were to devote your time, right, it's just like on the actual test itself, take your time, write out the values, like treat each question as kind of a puzzle to be solved, right, and figure the reference sheet is posted under resources, Lily, so you can I know I cut that off, but so you can always look at it. I showed it to you guys before, but it is posted on references, so you can see it. It's not like a hidden thing. And if you can't find it, just AP Comp Sci Principles reference sheet, and it'll pop up most likely. Okay, another question. How did I know that was the correct sum? Because I made the list. I made the list was one, like I made my n equal 3, so then I know what 1 plus 2 plus 3 is. That is the correct sum of 1 plus 2 plus 3 is 6. I counted on my fingers. I got it. I nailed it. So the idea is because you're making the list, saying, hey, which one works? Well, you give it a list. Like you make the list. Like you could have made the list 100 numbers if you wanted to, but like, why would you do that, right? Make it something simple that you know what the sum is pretty easily, right? And you can go from there. Like, oh, the list is 135, right? And then it's okay, it's 9, right? You can add those up fairly quickly, and and so you know what they are. For the square would be loop 1 to 4, and then yeah, and then move forwards would be the side lengths because that's you're saying the 4 is the sides, and then each time you move is going to be how long the side is. So if you move 10 times, move, then turn right and move again. It's I was out of the picture, but the point is that the amount of moves is how long the side would be, and the 4 is just how many sides in the square. Okay. Okay, anyway, my point is on the actual test, I'm doing this question too, But on the actual test, this is what we need to be doing. Here's what I would be doing. I'd be reading the question. Again, it seems complicated at first, but try to break it down into sort of pieces and write things out and be like, okay, so what do we got? Okay, so I'm writing down algorithm used to identify the maximum value. Okay, so I'm trying to find the max value in a list of integers. So there's two algorithms. The first one says we have a variable called max, and we're going to set it to -1. And we're going to iterate, which means, repeat through for each item in the list, basically, the list of integer values. If the data is greater than the value of the variable max, set it to max. Okay, so let's say we have a 1, 3, 5, okay? Um, all right, so we're gonna, and again, I probably would maybe mix it up. So let's do it out of order a little bit. Let's do 1, 3, 5, and then like 2. Okay, so we can, I don't know, you can't see my, I don't know, view, help, draw. Okay, good. Okay, good. Anyway, okay, so there's my list. I made up a list, right? That's what I'm going to use the same list for both to see if it's working. So, okay, so now I'm saying, all right, well, my max is 1, but I'm going through the first one. Is 1, it says if it's greater than the value of max, so is 1 bigger than -1? Yep, so I reset max to 1. Is 3 bigger than 1? Yep, so I set it to 3. Is 5 bigger than 3? Yep, so I set it to 5. Is 2 bigger than 5? Nope, so I leave it as 5. So did it calculate in that list the biggest value, the maximum value in the list? Yeah, it did. Now we're gonna come back to that because it's like it appears like it would work fine, okay? And so we'll look at the other one. We'll look at the other one, and then we'll see what the difference is, and see maybe that would make a difference. But we'll do it. So then the other one, algorithm 2, says we're gonna set max. So we're gonna use the same list, but we're gonna set max to the first data value. So not to -1, but to the first value. And I'm thinking, well, would that make a difference? And that's the clue in this question is like, well, that's the only difference. So that is not going to make a difference. So we set it the max to 1. Then we check is 3 bigger than 1. So we reset it. Is 5 bigger than 3? So we reset it. Is 2 bigger than 5? Nope. So it appears like it's working. But then I'm thinking, well, if this is -1, what if my list was -3, -2? Like, or I don't know, -4, -3. Like, what if my list was all negative numbers? Well, this one's going to set it to -1. And is -4 bigger than -1? No. Is -3 bigger than -1? No. Is -2 bigger than -1? No. So it's going to give me this value as the max when -2 is the max. So in other words, algorithm 1 doesn't work when you have negative numbers, when all your numbers are below -1. But this one always will work because we're actually setting, if we set the first one to -4, well, -3 is bigger, -2 is bigger, so it actually is going to give us the maximum value in the list. So yeah, so it actually took me looking through it, thinking it worked the first time, and then seeing what the differences between them was, and trying to figure out would that actually make a difference, one of them work. And I've read the answers, right? It says, well, do they both work? Maybe. I don't think so. One always works, but 2 doesn't work correctly. Even the maximum value isn't the first value. Well, that doesn't make that much sense. I mean, we saw that it did work, and it was seemingly fine. But this one, its answer is C. Algorithm 2 always works correctly, but algorithm 1 only works when the maximum value is greater than or equal to -1. So there's the -1 came into play in this one. Yeah, I kind of dislike that the math and comp sci are both days. I mean, one, I had to do 2 live streams already. Like I'm already doing that, but also you don't need to. Okay, wait. Someone asked for a calculator. Wait. Okay, reference. Okay, 12 and 20. I can do those. 12, 20, 54. Those are our ones that I'm looking at right now. I'm gonna write it up here. 12, 20, 54. And we'll find it. We'll figure it out. Okay, but just as another question. Oh, again, Nick, perhaps, Nicholas. I don't. Again, my 15 is different than your 15. So it's about modulo. We can find it, but I don't know what this might not be that one. So I'm gonna put 15 question mark mod. All right, so we'll find it, and then yeah, you're gonna have to tell me. What else am I doing? Calculator. Okay, you can't use a calculator on this test, so you don't need to bring one. But I made this video for my math students. Oh, wait, we gotta get the sound up. And we'll unmute that. So I made this one. So it has a similar vibe to ours, but for them, they need a calculator, so they need to remember it. So if you're doing your math, remember your calculator because there won't be any, right? Everyone's going to be needing one. So BYOC, all right? Bring your own calculator, please. For not my test, not for comp sci, please don't. Actually, you can bring it, but you can't use it, so you'll leave it in your bag. But bring it for math. So anyway, back to this. I covered up the chat. Hopefully you guys aren't saying rude things. Okay. Again, my point about studying is yes, if you've done these problems, if you see how you see how I'm doing them and taking time with them, I'm not just rushing through them. You do have plenty of time. More than enough, you have more time than you would on the actual like per question for the actual AP test. So like it's very very doable. Some of them are pretty quick. Some of them are you know it or you don't. And there are some that are like this where it's going to take a little bit to go through them. But those ones treat them as puzzles to sort of go through, try to sort of they might be trying to trick you a little bit, like, oh, the -1, why is that a matter? So we can do that. Anyway, now that's maybe not a real question. Okay, so it looks like we're doing 12. Ow. All right, so 12. Okay, I think I've done this one a few times, but we'll do it anyway. All right, so we have variables R, and again, if you notice, I'm doing it the same way as I did. I'm writing my variables out, RST. Okay, so the first thing, the arrow means I'm setting R to the value of 1, right? So R has the value of 1. S has the value of 2. T has the value of 3. So far, I think we're all on board there. Again, this is a sequence, right? So this is code. So we're working our way down, and like things that happened before could be undone and changed by things that happen later. So you can't just look here and be like, oh, R and S is 1 and 2, cool, because like we have to go in order and do everything. So we did this step, and this step. So now we're saying R becomes S. Well, so that means we're changing R to whatever value is in for S. So we're changing R to 2. Okay, the next one says S becomes what T is. So we're changing. So the thing on the left is the thing that's being changed, right? And then we're changing it to the value on the right. So we're saying S is being changed to the value of T, which is 3. So then so now at the end of this program, right, we have R has the value of 2, S has the value of 3, T has the value of 3. It just asked me for R and S. So displaying R is 2, and that's the only one with 2. It's got to be C. And the only one with S is, it's R is 2, and then S is 3. So 2, 3 is your answer there. All right. Not on computer, it's just paper. What was I doing? We got 20. Anyway, we in my comp sci, I would like some things for my live streams. I need an intro video. That one was a good start, just gives that vibe down. But I need an intro video, a theme song, a logo, and an end song. Okay. Now, the logo should probably be involved with the intro video and the outro video. The song might be involved in there too, so they kind of all tie together. So I'm just throwing it out there. Don't do it tonight. Okay, you have all winter break to do it. Okay, so do it, and then the class period that has the best one will get extra credit on their next test. All right. So now you have something to do to keep you occupied over winter break. Anyway, back to this. This question. Wait, didn't we do this question? No. Was it 9? No, 20 is what you said. Sorry. Okay, so this one is talking about digital images often represented by red, green, blue, which is RGB triplet, right? We talked about that, of each individual pixel. So every individual is a red, a green, and a blue. A photographer is manipulating a digital image and overwriting the original image, okay? Which of the following describes a lossless transformation? Okay, so remember, this goes back to the original question at the beginning, lossless versus lossy. So when I modify a file, when I compress a file, and what we're doing is we're changing the digital image, right? So we're modifying it, we're changing it, we're actually compressing it. So what this is saying is that if I'm changing the image and I make the image lower in quality, like if I compress it to send it so it's like a smaller size, whatever, and the person on the other end, when they get it, is it the same quality as when I took it? Or is it different? If it's the same quality, then it's lossless, right? We didn't lose any bits of information. All the information is still there. It's the exact same image. Every pixel is exactly the same. It's pixel perfect. Okay, that is lossless. And again, that could be applied to audio files, right, where the sound quality is exactly the same. It can be applied to videos, right, where there's the artifacting or it's the same resolution of pixels and frame rates and stuff like that, right? So it can apply to almost any file. But when we think about them, images is the first one we think of because we're compressing images. So if can we extract them and decompress them into what we originally was? That's lossless. Lossy is when you actually lose information. Okay, so if you lose information, it's not the same. It can be unnoticeable, right? I mean, when you send images through text or through iMessage or whatever, like they're being compressed, right? I mean, they're not sending the full version. If you take a full version, it's probably megabytes, but when you actually send it, they probably compress it down to one. But most people don't notice the difference because they're high enough quality that it's fine. If you're making a poster out of them, it might be an issue. Okay. Videos happen when you're sending videos through your phone. They want to compress it so that when it sends, it's sending less data through. So it takes less time. It's more fluid, all that good stuff. But again, because your screen on your phone is much smaller, you're probably not going to notice it. But it is being compressed. It's lossy compression because it is losing quality. Okay, so this says which of the following transformations is a lossless transformation. So which one isn't going to lose anything? So it says compressing the image in a way that may lose information but will suffer only small loss of quality. If I'm losing any information, that's lossy, that's out. All right, A is out. Creating the grayscale of an image by averaging the amounts of red, green, and blue and assigning this new value to the corresponding pixel. Okay, so here we're thinking, well, if I average it, can I undo that average? It's always like, whatever I'm doing, can I undo it? Because in the exact way. So if I said, okay, I have the red, green, and blue value of 1, 3, and 5. I'm just giving you a value. So the average would be 3, right? But if I wanted to undo that and figure out their RGB, could I actually figure out the red, green, and blue value if I knew the average of them was 3? No, because it could be, my values could be 3, 3, and 3, right? It could be 9, 0, and 0. It could be 0, 9. I mean, so there's a lot of variety of what it could be, and it doesn't have to be that, right? It could be 2, 3, 4, or 4. Yeah, the point is that there's a lot. We don't know which is red, green, blue. So if you average something, there's no way to come out of that average, right? Um, so and okay, so that one's out, right? Because that one actually does lose quality. Averaging is losing quality. We can't go back, right? Can't go back to the original. Creating the negative of an image by creating a new RGB triplet for each pixel in which the value is calculated by subtracting the original from 255. The negative of an image is reversed on the original. Light area is dark and dark here light. So in this case, we're subtracting from 250. So it'd be 255 minus each of these values. Well, then you could actually probably go back from that because you could just add I mean, you could, like, if you subtracted from 255, you could just, add, you could figure out the difference up to 255 and then figure out the value, right? So that seems like it's the answer. Modifying part of the image by taking pixels in one part of the picture and copying them to pixels of another part. Well, again, if you're copying pixels from one, you're kind of overriding one, so you don't know what those original ones were. So that would also be lossy. So A, B, and D are lossy. So the answer is C. Has everyone been C yet? Don't think that's a pattern. I think everyone has been C, but I don't know. Um, I'm glad you guys are enthusiastic about the. Yeah, I mean, I'll be in my room for. I'm almost positive Miss Saunders will be in her room as well, following the math exams for that period. Um, so I would just go to. I mean, I'd almost. I'm fairly certain she's going to be there. I know I'm going to be there. I proctored the morning test, and then I'll be there in the interim. So if you have any questions, I can go over them as well. Or if you come by my room, it's 225 if you want. All right. Okay, so if you have a fire, it depends on what kind of fire it is. If it's a grease fire, an oil fire, you do not want to throw water on it. That just makes the problem worse, okay? So don't do that. But if it's a normal fire, a non-grease fire, water would be fine. A fire extinguisher would be better for either situation. You don't, believe it or not, you do not want to fight fire with fire as well, contrary to popular idiom, right? You do not want to do that as well. If it's an electric fire, it's electric. Boogie woogie woogie chew. I think that's what you have to do. You have to do the electric slide. I'm fairly certain. All right. So if there are, I mean, I know there were more questions. I know I'm not getting there. I'm like trying to fully explain the concept of these questions so that you could apply the same concept to like 10 other questions should there be questions about lossy versus lossless. Like instead of just walking through the specific problem, I'm sort of making it more broad. So I get why it's not. Katie wants to know the difference between the www and the internet. Okay, World Wide Web (WWW) is sort of an application that is on the internet. Because okay, think about it like this: the internet is just like the actual It's like the hardware. It's the actual infrastructure that connects computers and devices together, right? I mean, my computer is connected to my router, which is connected to Comcast, which is connected to someone else's, which is connected to Hub. So if I send information, I can access servers that are connected to this. It's a network of networks. So it's the actual physical like wires connecting things together. I mean, they could be wireless and stuff. I get that, microwave, all that stuff. But the point is that it's the actual physical sort of connection. All right, but there are like computers and servers that are connected through the internet. www, the World Wide Web, is just an application that allows you to quickly access files and things through the internet. So it's an application that sits on top of the infrastructure of the internet. Like it's kind of like, I mean, you can almost think of it in its own way as it's like email. It's like email, like the email client, like Gmail, uses the internet, right, to send and receive emails. But it's its own application, right? It uses the internet itself, but it's its own application. I mean, I'm like iMessage or whatever. It uses the internet, right? But it's its own sort of application on top that utilizes the infrastructure of all the computers being connected, the internet. Um, but it's not the internet itself. World Wide Web is just like when you go to a browser, you're using the World Wide Web, you're using that particular thing. Okay, hopefully that. I don't see any other real questions. Oh, Jet's got some. All right. All right, these might be it. Did I do other ones that I already said? 20? Was there another one? There was one that I didn't know the number of, but it was about mod. So if we run across one that says mod, I will do that. 17. Ah, mod. Okay. All right. I mean, we've done this a million. Not a million. That's exaggeration. Also, I hate when people say over exaggeration because it's just an exaggeration. You don't need the over in there. Anyway, so but the point is that we've done this definitely a few times. This is one of the main use for using mod. So mod or modulus is basically um, dividing a number by another number. So, but then instead of giving the whole value, right? If I said what's 9 divided by 3, that's just 3, right? That's just giving us how many times 3 goes in there. Okay, modulus is different, right? 9 mod 3 says, okay, well, how many times does 3 go into 9? And then what's left over? In this case, there isn't anything left over. All right, so it's the leftover. It's the remain. I mean, it is the remainder. That's exactly what it is. But so that's what mod is. So we can use this when we're trying to figure out if numbers are divisible by another number, right? Because I could say if I wanted to figure out if 9 was divisible by 3, I could just check. Well, when I divide it by 3, what is the remainder? If the remainder is 0, like if this is true, then the number has to be divisible by 3, right? If it's not, then it's not. If it doesn't have the value of 0, right? When I mod 3, it's not going to be right. It's not going to be divisible by 3. So I mean I don't know what it's divisible by, but it's not 3. All right, so we can use this concept for even and odd as well because we know even numbers are divisible by 2, right? So we have to make that that step, right? That if a number divisible, when we divide by 2, when we mod 2, right? If there's a remainder, then it's got to be odd, right? It's not evenly divisible by 2. If there is not a remainder, it's either going to be a remainder of 1 or 0, right? But if there is a remainder of 0, it's even. If a remainder of 1, it's odd. So if I take a number, right, and I mod by 2, right? If it equals 0, that's even. If it equals 1, that's got to be odd. And again, that's a very useful tool, right? So it says we're trying to put this in a condition here to display odds. We want to see if it's odd. So if we divide the number, if we mod by 2 and it's equal to 1, that means it's going to be odd. If we divide it by 2 and it equals 0, that's going to be even, right? So we're never modding 1. That doesn't make any sense. Anything mod 1 is going to be 0, right? Because everything's divisible by 1. So like you're never going to mod 1, right? You want to see that the result of the mod, if the remainder itself is 0, if the remainder is 0, it went in evenly, so it's even. 2 went in evenly, so it's even. In this case, the remainder, if the remainder is 1 when we divide by 2, then we know that it is odd, which is what we're looking for. So it's D. I'll do 31, then 45, because they're in order. I think there's probably a better way, but whatever. Okay, 31. Yeah. Just want to make sure that. Okay, so actually, this would be an example of. Actually, did we talk about algorithms? Let me just give you the best answer here, and then because I'm not sure we actually this might be involving a heuristic algorithm, which which I said it wasn't. So let me just read. We're trying to figure out which the following describes possibly improving the running speed. Game's running speed can only be improved if the game is played between 2 human players. Nope. The game's running speed might be improved using a process that finds approximate solutions every time the controller player has a turn. The game's running speed cannot be improved. Game's running speed cannot be improved. Okay. So the answer is B. I mean, I think the other ones don't make much sense anyway, but the answer is B here because the idea is, and this is actually heuristic. The idea. So again, I'm not going to go into it, but just very briefly. Sometimes good enough is like a good enough answer is fine. Like if I'm trying to find, in other words, like there might be one specific best move that the computer can make, but to find it, it's going to take 13 hours. So what we can do in 13 seconds maybe is find a couple ones that are that are good enough, that are good, but not the best. So that's why finding one that finds a good enough solution. That's called a heuristic algorithm, the ones that finds a good enough solution. So good. Hey, Bella. All right, so that's 31. All right, so then 45. Few 21 people that are still here. High five. Here you go. High five. Put your hand up to the screen. Take a picture. Show it to me later so that you were involved. I'm going to keep it up here for another second. Get out your phone. Take a picture of us high-fiving virtually. Or do you want to do fist bump virtually? Okay, high five first. And then we can do fist bump. I'm going to do 3, 2, 1. Blow it up. 3, 2, 1. Boom. Sick. Virtual fist bump. All right. I don't know, man. Sorry. Okay. 45. Okay, so the over-exaggeration thing, it just sounds weird to me, first of all. Secondly, is it a technique used to create interest in a story? I disagree. I know you said you looked that up. I'm questioning that as a resource. I don't know. You didn't cite your sources, but I'm questioning your sources. Doesn't matter. Okay. All right. So, all right. So this one, I mean, this would be one that we should just work out, right? It says, hey, y is a positive integer, so it's going to be, 1, 2, 3, 4, 5, 6, whatever. And it says we're going to repeat it 3 times. So let's just pick a value for our y, right? So let's say y is, I don't know, let's do 5, okay? Because when you have numbers that are too small, like who knows what they're going to be, we'll do 5, okay? And basically we have the result. So we set result to 0. We could do it smaller first, but it might not help us. I don't know. I just figured I'd do this. So we're going to repeat it 3 times, okay? And then we're going to repeat this y times. All right, so what are we doing y times? We're going to set the result to the result plus 1. Okay, so our result was 0. Now our result is going to be, we're going to add 1 to it, right? And we're going to do it, in our case, 5 times. So we're going to add 1 to it 5 times. So 1, 2, 3, 4, and so now 5. We've done it 5 times. So our result is the same thing as our y, okay? And then they're going to repeat this 3 times, right? So we're going to, but the next time, right? The next time our result is no longer starts at 0. It's now 5, right? So the next time, right? The next time we run it, it is 5. The next time the big loop runs, right? It's going to be 5, then 6, then 7, then 8, then 9, and then 10. Then the next time it runs, it's going to be 11, 12, 13, 14, 15. So it basically is going to do our value y. Like these are each of the results of the loops. It's going to do y 3 times. So it's going to be 3 times whatever this is. So 15 is 3 times 5, right? So it's going to be 3y. Okay, cool. I'm reading. Okay. Okay, 43. No, is it 43 one? Is this 43? This is 45. Okay, I'll do 43 and then I'll finish up with Jet. This is only because they're in order and it's easier to do, but I'll do 43 here and then 58. 43. All right, so it's a mystery procedure. I think someone might have asked about this before, but in context. All right, 43. We have a procedure and it's not telling us what it does. That's why it's mystery. But it does take a number as a parameter. So we give it a number and it's going to do something. We got to figure out what it does, right? And we could read through the answers here, but I would like to get a general idea of what it's doing first. So let's say our number that we give it, our num, let's say we give it, I don't know, like 8. Okay, I don't know. I picked a number. It's low enough to work through. Okay, so we're going to repeat into the numbers less than 0. Okay. Our number is going to be our number. So first and foremost, we subtract 2 from our number. So our number starts out as 8, right? And now it's 6. Or I'll say it starts out with 8, and now we change it to 6. If the number is 0, return true. Otherwise, return false. Okay, well, it's not 0, so it's not going to be true. So otherwise, it's going to be false. Okay, so it looks like we're going to repeat this. Okay, so we subtract 2, we get 4. It's not 0, so we don't return. Wait. This doesn't work. Okay, because the first time running through this, right? Return. This is a good thing to know. It does say it on the reference sheet, but when you return, again, I'm wondering if this is actually part of this one. I'm pretty sure we may have covered it, but when you return a value, your procedure's over. So once you hit a return value, procedure done. Okay, so the idea is, okay, 8. So we change it to 6. If it was 0, it's not. It returns true. Otherwise, we return false. So what does it do? It returns false. Okay, so we're done. It doesn't keep on going, right? It doesn't, like, only this part repeats. Wait, this is dumb. Okay, I'm being dumb. I'm going to do this again. I'm going to do it better, and I'm going to do it betterer. Okay, so let's do this because we have to look at what's actually happening in this. I read this as a useful piece of code, but it's really not. But the point is that we have a number. Let's just say our number is 8 because I picked it. Fine. We're going to repeat into the numbers less than or equal to 0. So All right, so we take our number, 8, and I'm going to repeat this loop. It says repeat this loop until it equals 0 or less than 0, right? So, all right, so we have 8, then I have 6, then I'm going to repeat it to 4, then repeat it to 2, and then repeat it to 0. So now it's 0, so this loop is done. Like this repeat until loop is now done. If the number is 0, return true. So in this case, we're going to return true, okay? Otherwise, it's going to return false. So then we have to think about, well, what is this doing? Well, what if I picked a different number? What if I picked 7 as my number? Well, what would happen, and because I'm subtracting 2, I picked an odd number in this case just to see if it changed it. We're going to start out with 7. Then it's going to subtract 2. Then subtract 2 again. Oops, 3. Then subtract 2 again, and it's still bigger than 0. Then I subtract 2 again, and I get -1, which is less than or equal to 0, right? So this loop stops at this point, and I check. Is it equal to 0? Nope. So it returns. So when our number was 8, it returns true. When our number is 7, it returns false. All right, so maybe that gets us thinking, hey, this is going to return true when it's even, and it's going to return false when it's odd. So let's see. The procedure returns true when the initial value of number is 2, and otherwise it returns false. Procedure returns true when the initial value of number is greater than 2, and otherwise false. The procedure, so it's getting the idea of greater than 2 doesn't really matter in this case. The procedure returns true when the initial value number is even, otherwise is false. That seems pretty good. True when the value number is odd, otherwise it returns false. No, it's true when the number is even, because eventually if you subtract 2 a bunch of times, you're going to eventually get to 0, and if it's 0, it returns true. If it's odd, you're going to eventually go down to -1. So the answer is POW. If it's true when the initial value is even, otherwise it is in fact false. Okay, last one from what I can tell. Nope, I didn't scroll, dang it. I'm an informational YouTuber. I'm literally right here. That's super rude. 58. 58 is towards the end. Here we go. Click, 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 click. Bring your calculator for your math test tomorrow, but not for the comp sci test. That's my favorite. That's my favorite song. Okay, 58. Okay, we're talking about data, metadata. All right. So the metadata, I wonder if this is actually part of it. I'm going to go over it anyway, and this is going to be the last one. I think we're good. Wow, an hour and 15 minutes? What the heck? What am I doing? All right. When a cellular telephone user places a call, the carrier transmits the caller's voice as well as the voice of the person who's called. The encoded voices of the data are the data of the call. Okay, so that's the data, is the voices. In transmitting the data, the carrier also stores metadata. The metadata of the call include information such as the time the call is placed and the phone numbers of both participants, for which the following goals would be more useful to computationally analyze the metadata instead of the data. Okay, the data is the actual voices. The metadata is the time and who's calling. Okay, so the actual voices on the lines, the time, and the numbers of who's calling. Okay, so determine the caller if a caller frequently uses a specific word. Well, we would have to know what words they're saying, which is the actual data. So that is not part of this, because it says we want to use what's useful when we use the metadata instead. So not that, right? Because if the using a specific word is the voices, part of the voices, that's metadata, or sorry, that's data in this case. That's the data that we're talking about, so it's not metadata, so that's out. To estimate the number of phone calls that will be placed next Monday between 10:30 and noon, that sounds pretty good because that is literally the time that is taking place, and that's the metadata. Metadata is the time, so 2 looks good for metadata. To generate a list of criminal suspects when given the telephone number of a known criminal. Okay, well, if you know someone's telephone number of a criminal, you could look at who they're calling, and then you could figure out their suspects, right? So the idea is, in which part is that the actual voice, or is that the numbers of who they're calling? It's the numbers of who they're calling. That's metadata. So 2 and 3 are the answer here, which again, for some reason, is C. Thank you. I do appreciate that. No, I don't think so. Pretty careful, you know. Now that the adpocalypse has come, you know, you can't be too careful. They'll demonetize you, you know. Wait, can you get demonetized before you're even monetized? I don't know. but I think we're good. Anyway, we have dwindled down to 15 loyal users who were doing great. So hopefully we got all those. I mean, there are of course other questions there. Some of them are more straightforward than others. But again, the point is, this one was a word-based one, so there's not a lot of value. But I would, or not a value in writing some of it down. But write a lot down, right? You know, jot on it. Jot down things, what variables mean, what they do. Circle what you're trying to find, or even number, odd number. Maybe you're trying to figure out what the procedure does, right? I feel like a lot of times it's what's confusing about when you read through the question one time, it's confusing. Like you don't even know what they're asking sometimes. So read through it again, logically work through, okay, what are they asking? What would that make sense? It says right there, the data is the voices, the metadata is the time and the phone numbers. Okay, based on that, you should be able to answer a question like this, right? All right, it is sleepy time. Yep. And again, if you have any other questions, I'll be available in my room from I don't know what time my test actually ends. 10 maybe. I think it's 10. So I'll go back to probably be back to my room at 10:30, something like that. Maybe 11. So I'd say like 11 to 12 is going to be like prime time for asking questions. I'll probably have to eat in there somewhere. I don't know. I'll figure it out. But I'm done. Kelly. All right. Anyway, scoring guide. What's that? May take up to 30 seconds. So I don't know what it's doing. But anyway, I think we are good. She sent me a remind. Oh yeah, she did. Wait, no, she didn't. I don't know. No one sends me reminds. Oh wait, some people did. Dang. Hold on. Okay, I'm done here. Yep, I think we're good. Okay. How about comp sci caramba? Nah, comp sci later. What was the other one? Comp. Oh, I got it. Ready? I got it. This is my outro. Okay, everyone, prepare. I'm we're oh wait, I gotta get this ready. Sorry guys. All right, ready? What we got? Offline? No, ending. There we go. Bye guys. We're leaving. We are straight out of Comp Sci. Boom! Killed it. Oh wait, they can still hear me. Still killed it.
Mic off.